Having seen about the mole concept and understood the relationship between moles, particles, mass and volume of the compounds, we will now go to understand how these molecules are present together in the stablest form. So in this case, now this part will be dedicated to something called as a molecular and empirical formula of these particular compounds. So what are these molecular and empirical formulas? That let us see in these cases. Already we understood what is molar mass, that was correlated with 1 mole of a compound. So any molecule in a particular mole will be in its stable form. As an example, we have taken water. Now what is water? The formula of water, you can write it as H2O. What is present in water is 1 atom of oxygen and 2 atoms of hydrogen. Together, when all this come, that is when they form a perfectly stable molecular form. So in this case, what we see is that this is the simplest form as well as the overall arrangement of atoms to form a stable compound. So what we understand by a molecular formula is it is the actual number of atoms that are present so that the molecule becomes stable in its overall state. We have some more examples here, which is glucose. Where do you get this glucose? Glucose is one of the very important food component which we obtain from plants. Even by artificial ways we prepare it. So any food components that are being prepared, we call those mainly under glucose, fructose and other components. This is the formula of glucose, C6H12O6, which indicates that for this compound to be stable in nature, 6 carbons, 12 hydrogens and 6 oxygens combine together. It is only when such a lot of atoms combine, this compound is stably formed. Carbon dioxide, the formula of carbon dioxide is CO2, which once again indicates that 1 carbon atom and 2 oxygen atoms combine together to form a stable compound called as carbon dioxide. The next example, methane, CH4, 1 carbon, 4 hydrogen atoms. Dinitrogen pentoxide is N2O5, 2 nitrogen atoms and 5 oxygen atoms. This is how stable atomic combinations happen to form a molecule as such. Now, having seen this molecular formula, we shall go to the next one, which is empirical formula. Now, what is this empirical formula? That is also a part of molecular formula, but in molecular formula, you saw that many atoms combine together to form a stable component. For example, we went through the formula of glucose, C6H12O6, where 6 carbons, 12 hydrogens and 6 oxygens combined. Now what is this empirical formula is? Same formula. We are not concerned about how many atoms are required to combine. We just represent this in the simplest ratio. What is the simplest ratio? The general divisibility factor for all these 3, you can find out that it is 6. So what is the empirical formula of this? This is CH2O. Basically what we want to tell here is that the ratio of combination of carbon, hydrogen and oxygen is nothing but it is in the ratio of 1:2:1 with respect to carbon, hydrogen and oxygen. So this is what is empirical formula, that it represents a particular compound in its simplest ratio of combining atoms. So this is one important difference that we have to understand, that in molecular formula we are more concerned about total number of people who are enrolled so that they form a stable compound, whereas in empirical formula we just are concerned about the simplest ratio which is there. That is the difference that has been shown here. Empirical formula are also called simplest formulae, while molecular formula of a substance is always the integral multiple, which means that suppose if I have this CH2O, if I multiply these into 6 atomic forms, I can get it as C6H12O6. So what has happened here? This empirical formula, when you had the integral multiple with 6, you got the corresponding molecular formula. Now if it is an ionic compound, you always get those compounds in empirical formula only, because the stablest forms in the ionic parts, because since ions are free moving particles, they combine together in the least possible ratio that has been present. It is just that the organic compounds which are there generally may have more molecules with them. So let us see some examples in these cases. Some examples which I have gone through many a times now. Ammonia, NH3. Now you see that both molecular formula and empirical formula are same, because the very stability of this ammonia is in the ratio of 1:3. And one nitrogen atom is combining with 3 hydrogen atoms. So here both become same. So you can see various types here. Even for carbon dioxide you can see CO2, CO2. What changes is for ethane. Now the formula of ethane is C2H6, but its simplest ratio when you see, 2 is the divisible factor here. So if you divide this by 2, you can get directly as CH3. So for ethane you are able to see a change in the empirical formula, because this molecular formula can have a more simpler ratio in that case. Fructose, once again glucose and fructose, the study of this you will be doing it later, though the formula seems exactly same, but the way that component is present is a little different. So a deeper study regarding this you will be doing it in the parts of biomolecules. As of now, be aware that the formula is C6H12O6 and its simplest form is CH2O. Sulfur, the symbol is S, but the molecular form of the sulfur is S8, and simplest because just the atomic form is to be represented, it shows as S. Benzene is C6H6. This is how the structure of benzene. We are going to have an extensive study about structure of benzene and all, C6H6. But the divisibility factor you can see it to be 6, and therefore CH is the empirical formula which has been found out there. The last two examples, if you see in the molecular formula, they have just put a hyphen mark there, because as is been conveyed, in molecular formula of ionic compounds, it will exactly be the empirical formula, because ionic compounds combine themselves in their simplest ratio only. Whereas organic compounds will combine according to their stable formulations. Now since these molecular formulas you can see here, sodium chloride, calcium oxide and all, NaCl, CaO, they are just present exactly as their empirical formula. So with this basic, further we need to now analyze, if you are given the percentage, how will you calculate which atoms are there, all these aspects you have to study. But before that, this specific concept of molecular formula and empirical formula has to be crystal clear with us. Molecular formula is the stable state of the compound, whereas empirical formula deals with the simplest ratio that can be possible with respect to organic compounds. Inorganic compounds, which are generally made up of ions, will be present in their simplest ratio. So this is a basic part of this, and an extensive study of this you will be doing it in the next part. Thank you. Sai Ram.